Hi everyone, I'm Francis here. This is my first time recording a YouTube video. And today I am going to record a video explaining the code that I've written to build a bank in Solidity. So this exercise is done in response to the Quest book challenge. So before I dive into the code, let me briefly explain what are the requirements for this exercise. So quest 1 is to build a bank with Solidity that allows users to deposit and withdraw amount in ETH and also allow users to earn an interest rate. And quest 2 is we build on top of quest 1 by adding a connection to Compound, which is another decentralized application that is built on Ethereum network that functions as a bank that allows users to earn an interest rate. So what we do in quest 2 is to tap into the interest rate provided by Compound. So that the users who deposit into our bank can earn a real interest rate. And in quest 3, we are going to expand the type of currencies that users can deposit and withdraw to all other ERC20 tokens in addition to ETH. So that is a brief explanation of what I will be going through with you. Okay, so now I will go to the remix and I will go through the code that I've written. So first of all, the first few lines are interfaces, which allows users to initialize the smart contracts on the Ethereum network so that we are able to tap into contracts that have already been deployed. The first interface is Compound ETH, and this is basically the ETH, the tokens that we will receive from Compound once we deposit our amount to Compound. And this Compound ETH will allows us to earn an interest rate, and when we redeem the amount from Compound, we will be able to redeem the principal plus plus interest rate that we earn from Compound. The second part is about Ierc20 Interface, and this is basically what the standard implementation of the ERC20 token. The third part is the third and fourth part are the Uniswap v2 router, and this is basically a router to allows us to be able to swap ERC20 token into ETH or from ETH into other ERC20 tokens that users select. Next, we'll dive into our smart bank account contract. So first of all, we initialize the state variables that we are going to use in the functions, and I'll explain those state variables and how they are being used in the functions below. So first function is addBalance. This is basically a function to allow users to deposit balance in ETH into our smart contract or smart bank account. So within this addBalance function, you can see that it will keep track of the users, the deposit amount that users deposited into our smart bank account. And then what it does is it will send the amount to Compound, and in return, the smart contract will receive Compound ETH The next function is get contract balance. So this function is to get the total amount deposited to this contract by the users. This get contract balance will tell you how much deposit has been received from various users. And the next function is get compound balance. So this get compound balance is basically a function to keep track of the compound ETH that this smart contract receives from compound from depositing ETH to compound. So as I said, once the smart contract deposit ETH token to compound, it will receive compound ETH. And when you redeem the amount from compound, you will receive the principal plus interest from compound. And that is basically what this compound ETH can give you. The next function is get total ETH, CETH amount. So this is to keep track of the compound ETH amount. But the difference between this and the function before that is that the function before will give you the amount of compound balance in weight. So as you can see, I multiply the compound balance by the exchange rate stored. And this is basically the exchange rate that converts the compound ETH into weight. Okay, the next one is conversion rate from compound balance to the contract amount. This is the conversion rate that allows the contract to convert the amount of compound balance, which is the principal plus interest rate, to the deposit amount that users deposited. And we are going to use this later for users to redeem amount of deposit that they have put into this bank account. We'll use it later, so I will explain it later, how we can use it. The next function is conversion rate from the contract balance to compound ETH. And this is also some conversion rate that we will be using later for users to be able to withdraw the amount from compound. And the next function is addBalance Ierc20. So this function is basically the function that allows users to deposit Ierc20 tokens to this contract. And this contract is formed of three functions. One is the addTokens function, which you will see later. And then swapExactTokensforETH and depositToCompound. So basically there are three steps that are being executed by this function. Adding tokens from the user, which is the user deposit tokens to this contract. Once that has happened, this contract will convert the tokens into ETH, and that is done via the Uniswap swapExactTokensforETH function. And once the tokens have been converted into ETH, it will be deposited to Compound. So those are the three steps that are executed by this function. The next three functions are basically the steps that I have explained before. First one should be this addTokens. So this addTokens function is basically a function that allows users to deposit Ierc20 tokens to this contract. Once that has been deposited, the contract will swap exact tokens will swap the tokens into ETH via the Uniswap function. And you can see that I initialized the Uniswap v2 router address via this line. And I require the balance of this contract to be the ERC20 token balance of this contract to be greater than 0. Otherwise, user will receive this error message, which is insufficient token to swap. And once that is done, the contract will deposit the ETH to compound, and that is via this function depositToCompound. And in return, this contract will receive compound ETH, which is this state variable will keep track of the amount of compound ETH that is received by this contract. And I've also written a function which is to get allowance ERC20. So remember, before users can transfer the amount of ERC20 tokens to this contract, they will need to approve the amount of ERC20 tokens first. And that is something that has to be done outside of this smart contract. So once the users has approved the amount, then this allowance will change, and it will give this smart contract the authority to be able to use to spend this amount to do whatever that the contract needs to do, which is to convert it into ETH and then deposit the amount to compound. And this get allowance ERC20 is to check the allowance that users has approved approved to this smart contract, so that this smart contract is able to spend the amount. The next function is so I've already explained swapExactTokensforETH function, and then the next function is swapExactETH for tokens. So this function is used by the smart contract to convert ETH to any other ERC20 tokens that is selected by the user when the user wants to withdraw the amount from this smart contract. So remember, I said that we expand the currency or the tokens that users can deposit and withdraw. And this is the function that enables this contract to convert the amount from ETH to other tokens before it can be withdrawn by the user. The next function is to get balance in way. So this function allows users to check the amount of ETH that is available for withdrawal or that has been deposited to this smart contract, and this amount will include the this get balance in way will show you the amount that has been deposited to compound plus interest that users earn from compound. The next function is the withdrawal function. So in order for users to withdraw, I have put in the condition that the withdrawal amount in way must be less than or equal to the get balance in way. Basically, what this means is that users cannot withdraw more than what is available based on what they deposited plus interest from compound. If it's more than that, then it will there will be an error showing overdrawn. So this is where the conversion rate will comes into play. Basically, the users will specify the amount to withdraw in Wei, and in order for the smart contract to retrieve the amount from Compound, it has to be converted into Compound ETH. So this is where the conversion will be used to convert the withdrawal amount in Wei to Compound ETH. Remember, Compound ETH is not one-to-one when to the amount that the users deposit, because there will be interest earned by the amount deposited. So it's not one-to-one. So that's why we have to calculate the conversion rate. And what this withdrawal function does is also that user can withdraw partially the amount that they have deposited. So it's not a full withdrawal, it is a partial withdrawals. So users can withdraw, let's say they deposit 100 ETH, they are able to withdraw 50 first time, and then another 50 plus interest rate the second time. So this can be achieved by this function. And the next function is withdraw in Ierc20 token. So this function allows users to withdraw the amount in the Ierc20 token that they choose. So user can specify the amount to withdraw in Wei, and also the Ierc20 token that they wish to withdraw from the smart contract. So by specifying the Ierc20 token address, the user will be able to withdraw the amount in whatever Ierc20 token that they choose. So similarly, the amount withdrawn in Wei has to be less than the balance that users deposited plus interest. Otherwise, there will be shown an error, overdrawn. So that's basically what are the functions that are available for the smart bank account contract. And you can find the code, the full code in my GitHub, which I will put a link down below. So thank you very much for watching, and let me know if you have any questions in the comment section. Thank you. Bye.